Okay, Assalamualaikum and good morning. Today we try to continue what we postponed from the previous class. So today we try to touch about the HVAC applied acoustic abbreviation on measurement. Actually, we try to measure what differentiate between the frequency and then what the uh, decibel itself. So on this topic, on lecture on week 6, we try about talking about the noise. So by the end of the lesson, should be can identify instrumentation for noise measurement, and the second, we can get the identify type of the frequency analysis in sound meter, and then the last is we can understand about the function of the dBA, decibel in the A level. So dBA is short form by the decibel. A is a level, level A. So we have the level A, C, and Z. So today we try to touch about only level A. Okay, about noise. We know noise. In the system of the HVAC, they will create the mechanical work, and then also the vibration from the air itself, to the duct system. Maybe they have several part there in the duct system until to the diffuser. So every diffuser, as we know, they have the like the fin to direction of airflow. So from this direction airflow, so can create the vibration, and then will be create the noise. So maybe noise is we can sound from the other sources. Not only for the from the air itself, also from the mechanical work, maybe in the room, in the space system, maybe can create more than one of the source of the noise. So some of these noise will be create one new number level of the noise itself. So that's why we need to understand how to measure, and the definition first. We can recognize the source and then the level of the noise itself. Mm. Okay. In the introduction, first we understand, unwanted noise makes a workplace uncomfortable and less productive, productivity. So this is a common knowledge about the noise. If we got receive the uncomfortable condition, so maybe the uh, performance of the person will be calm down. Is not perfectly perform in their work. So that's why we try to get what the parameter, for the condition uh, uncomfortable of the uh, worker. So today we try to understand to get the parameter comfortable, uncomfortable from the noise. So the second, our introduction, when the people are surveyed about workplace comfort, they most prevalent complaints involve the heating, ventilating, and air conditioning system. So most of the survey, they talking about the concern about the HVAC system will be contribute in comfort or uncomfortable condition. So as we know, yeah, HVAC will be play with the temperature, humidity, and air quality itself. So beside that, the contribution from the HVAC also can create the noise. So we also try to reduce to cover this uncomfortable from HVAC system. Then the last of our interaction, the problem they cite most frequently, aside from the temperature control, have to do with excessive noise and the vibration. We can find out the source, and then we try to uh, prevent. We can do the prevention to the this condition. Yeah. But before that, we can identify first what the problem can cause this to create the noise in the workspace. Okay, now we go to how to measure the noise. There are many reasons to make noise measurement. Noise data contain amplitude, frequency, time of phase information, which allow us to, So we can identify the noise, by measurement. But what we need to measure actually, yeah, is it frequency, is it the decibel level or what? So from this activity we can get identify and locate the dominant noise sources, and then we can optimize the selection of noise control device method material by this identify. Once we get the source of the noise, and then we can understand how to cover this trouble. And then the third bullet said evaluate and compare noise control measures. We try to evaluate. So after we get the reading, so this reading, we need to reduce, because this number maybe is exceed a lower low in the human comfort. So how we try to reduce this number? So we try to identify the source first, and then we try to solve the problem. That one we call the evaluate. And then we go determine the compliance with noise criteria and regulation. Okay, we go to refer reference that said this is suitable to our condition, because whatever we do, we need to refer the standard, the regulation. This one will guide us to do the right thing. And then quantify the strength, power of the sound source. After we sorry, we collect the data, and then this data we can plot in the regulation rule, and then we can reduce the power by the system. Then can this system also can our identify that can reduce the certain level. So we should know first the prevention system, because some they need to more power to reduce, because not all can cover in this range of the prevention level. So some maybe we can add the system troubleshooting to improve the what we call the prevention system. So maybe we can try to find what the device can reduce in that range of the power. And the last one, determine the acoustic qualities of the room and its suitability for various uses, and many more. Mean that maybe this source will be impact to the several space or region. So if we try to solve, mean solve to all space on region. Yeah, so we can make sure the system we evolve to cover the noise can cover all region. And then performance or characteristic, yeah. So based on the performance of characteristic, we can identify frequency response, yeah, this parameter, what the parameter we need to collect, yeah, in the site. So what we data we need to collect. So the first maybe frequency response, the range of the frequencies over which an instrument reproduces the correct amplitude of the variable being measured. So mean that the response frequency we can collect data from the source. So how much, how many frequency that create from the source, and then if we refer to the device, yeah, several device, they can create also can record the level of the noise. So you can see the microphone, they can record or capture the source. Yeah? The noise from the source is around 2 decibel. Low from there, maybe the microphone cannot catch the source of the noise. And then tape recorder, they play will from the 1 until to the 3 decibel. If you low the net, so the recorder, tape recorder cannot catch the source of the noise. And loudspeaker will be created in the 5 decibel. That's uh, illustration, how the device can function in the several range of the decibel. Okay, performance characteristic, continue from the performance characteristic. What parameter again we need to collect? Dynamic range. So dynamic range itself is a mean amplitude ratio between the maximum input level and the instrument internal noise floor. So mean that the dynamic we can collect from the several source. Yeah. So as we know, when we go to several room region, actually they will create several noise from the several sources. Let's say from the HVAC system, from the maybe from the uh, system, sound system, yeah, itself, and then from the maybe from the uh, people movement, and then maybe from the uh, people talking, and then that one we can say is the source of the noise, and then some of this noise we call the noise floor. So dynamic range, we can measure the amplitude ratio from the several sources. Yeah. So all measurement should be at the least 10 decibel greater than noise floor. Mean that if we create the source of the noise, mean that if we measure in the level of the noise floor, there should be noise floor is lower compared to the source itself, because source itself, yeah, we measure directly from the source. Then the noise floor we can measure exactly maybe center uh, from the space. So that's why, yeah, when we measure noise floor, maybe far away from the source, but we collect from the other sources, then we can measure, or we can collect the data, yeah, from the several source. But actually, the noise floor is come far away from the source itself. So from the source itself should be is 10 greater, yeah, 10 times sorry, 10 dB greater, yeah, than the noise floor, because they need to transmit, yeah, from the source, yeah, to the noise floor measurement. So that's why we need to, when we collect, the source, yeah, is greater, yeah, from the noise floor. So if we go to the typical dynamic range of meter is 60 dB more is better. Mean that if we measure in the noise floor in the one space, yeah, it's not more 60 dB or 80 dB, because if more than that, is we can consider as uncomfortable to the equipment. Yeah? And response time, the time interval required for the instrument to respond to the full scale input, limited typically by output device like meter, plotters. So mean that when the response time, we need to need time, yeah, or period time, yeah, to the transmit, yeah, from the source. So within the measurement, yeah, from the source, yeah, they have several distance. So from this distance, the time, yeah, respond, yeah, maybe need several time to transmit, yeah. So that's why we can consider, yeah, this one is if the source is consider high frequency or a low frequency, so the response will be calculate, yeah, from there. So if the transmit need more time, maybe the source is considered very low noise. That one is a response time. Yeah. So we have several measurement, several device equipment to collect the data. Maybe this uh, measurement, yeah, will be related to the measurement for the human comfort, and then maybe relate to other condition. So maybe in comfort, human comfort, related to human comfort, maybe they will use typically equipment that relate to the ear of human. Yeah. So when we relate to the human comfort, maybe we can use the sound level meter. Yeah. Okay. If we look into the text, yeah, sound is measured in decibel with use of the sound level meter, and then this sound, yeah, actually is measurement in the level of the ear human hearing. So if we relate to the human comfort, mean that the equipment should be can measure the condition. That condition is related to the condition of normal human hearing. So the level we will play a certain condition, yeah, certain level of the frequency, certain level of the sound pressure, like that. The sound level meter responds to sound in approximately the same way as the human ear, but it gives us an objective of measurement of sound level. The sound the sound to be measured is converted into the electrical signal by microphone. So we have a microphone and the end of the sensor, and then the microphone will be give the signal, yeah, electrical signal to device. And normally condenser microphone are used for precision grade instrument, And since the signal is quite small, it's necessary to amplify it and then convert for display of the meter. So actually the frequency will be converted from the microphone to the electrical signal. And then from this electrical signal will be reading in the display to convert again in the sound level meter. That's how the device works. Okay, this one the measurement uh, in the sound level meter. So you can see the graph here. We plot from the within the decibel level dB on the Y direction, and then the X direction is the frequency. So we can measure the certain condition. If we play with the frequency 63, they will record in the dB, maybe around 50. If we increase the frequency, the noise will be increased. So mean that the look like the linear condition. Back to the text. When measuring the sound level from the source, the meter should be held at a distance of 1 meter from the source. So that how to we use the meter, sound meter. Should be we hold in the 1 meter from the source. Yeah, the rule of the this for this equipment. The sound level in decibel A scale can be measured at the each center frequency using the filter, and a graph can then be drawn for the example shown below. This one the example. So level A of decibel, mean that the level for human hearing. That if we compare to the this frequency, we will play like the human ear condition. So if the human condition is from this to this frequency, mean that the measurement should be play like the human hearing normally. And then this give an indication of sound level at the different frequency. This can be useful information can be used to design appropriate attenuation and acoustic treatment at particular frequency. Okay, this one maybe we can use maybe to design like the room theater, and so on, that will be used for the human, like the hall. So they will measure by using decibel A level. Yeah. So because this one they will be implement to the human comfort, that's why we use the level A. Yeah. Okay, this one actually the condition measurement video. You can check by this link, because I cannot use this link in this online class. So very difficult to share to condition. In the same time, to better you check by yourself. This link YouTube. So this YouTube explain how to measure uh, the decibel A by using equipment. Okay, another one. This one is other parameter to measure. This one we call a noise dosimeter. So combine sound pressure and time for employee exposure monitoring. And then this small microphone can be worn at the ear, on the collar, or on the shoulder. So the purpose is to get the noise exposure toward the working during working in their workplace. So this link also teach us how to use uh, noise dosimeter. So you can check by yourself later on. This link, YouTube link. So you can learn something how to measure by using this equipment. Another octave band analyzer. So this one is related to the frequency, related to frequency measurement. So as we know, we have several octave, in the band system. Last time we already learned about this octave level, maybe around seven octave level, like the singer. Uh, Last time I said mentioned the Mariah Carey can reach seven octave, for the achievement of the frequency. So this one we measure the octave, of frequency. So real-time analyzer or octave band analyzer are special sound level meter that divide noise into its frequency component. So the reading will be come out with the frequency reading. And then electronic filter circuit are used to divide the sound or noise into the individual frequency band. So every source will be come out with a single number of the frequency. Most octave band filters set provide filter with the following center frequency, 31.5, 63. So as mentioned just now, they will come on with a single number of the frequency. For more detailed analysis, the spectrum is sometimes measured in the 1/3 octave band. So within the octave, they will can separate by several conditions. So as we know, every octave they have the range of the frequency. So let's say the lower frequency is come from the 31 until to maybe 63, and then within the 31 and 63 they divide by three of the level of frequency. We call that one is the 1/3 the octave band. So they will play very detailed, not only mention about the octave itself, but also the number in the 1/3 of the octave. Octave band analyzer, still in the octave band analyzer, you can see the reading, how they measure. Real-time analyzer or octave band analyzer are used to help determine the adequacy of the various type of the frequency dependent noise control. Select hearing protector because they can measure the amount of the attenuation, how much sound is weakened and offered by the protector in the select octave band. So if the source is play with the high frequency, mean that we need to protect the walker from the high frequency by using the ear protector. So ear protector also have the specification. So maybe can cover only several range of the frequency. So that's why we need to measure first before we launch the ear protector to the walker. So we can identify the what frequency. Last time I have a experience also in the oil and gas. Oil and gas also have the high frequency when the operational in the piping system. Inside our piping system, they have the high pressure, and this pressure will be create the high frequency from the inside of the piping system. So this frequency will penetrate the piping system to the environment. So very noisy. So even though they release to the outdoor, mean it's not cover in the indoor system. It is outdoor system. The piping system will create very noise system. So because of noise is near to the piping system, when we check to piping system condition like the pump, And then we can check also the pressure inside. We believe we pressure, so we need to maintain the pressure in the piping system. So we need to collect every time of the pressure in piping system. So the worker will come in the certain scheduling of collecting data. So they come very frequently. Then the worker need to cover their year. So this year, before the company launching to the worker, they need to identify first what frequency, yeah, in the site. So that's why they come with the protector in that range, yeah, already identified by company. And then we can analyze this frequency content of noise. Is it the constantly, yeah, or this one is consider only certain time, yeah, we will play with the high frequency, or this frequency is constant. That's we should need to identify. And then sound measurement, sound level meter. Sound level meter are programmed to account for the human ear sensitivity to certain frequency. The meter measures the sound pressures in all the different frequency, correct them all for the human ears, and then present us with a single figure presentation of the noise. Yeah. So even though we have the several sources there in the workplace, maybe we can come with a single number. So we call the floor noise, mentioned in first slide, in beginning slide, already explained. And a wake measurement, decibel level A, that combine octave band sound data into a single number descriptor. So we need to collect data with the launching with a single number of uh, frequency and pressure level. The letter A indicate that the sound has been filtered, yeah, to reduce the strength of very low and very high frequency sound, much as the human ear does. So mean that the dBA already protected, already mean what we call setting, yeah, setting by human comfort. Okay, weighted sound level in decibel. Maybe we can collect from the several activities. Yeah, so some maybe from the engineering activities condition. So let's say, the first in the left table, on the left table, set weighted in the 120. That one is uncomfortable loud 30 tons, as loud as 70 dBA. So noise environment, military jet airplane take off at the 50 feet. Yeah, I mean the source this level is can come from the military jet airplane. So that's why in the side they use the ear protector. So we can make sure from this measurement to protect system, protected system, ear protect system can cover around 120, yeah, decibels. And then when we go to the other condition, yeah, giant flyover, yeah, around 100, propeller plane, yeah, flyover is around 80 decibel, and then until to the uh, extremely quiet around 10, yeah, 10 decibel. The main advantage with the A weighting are as follow. It is adapted to the response of the human ear to sound. It is possible to measure easily with low-cost instrument. Why we need to measure the of the A Waketon level. So most of the noise are measured in the Waketon sound level in dBA. So whatever noise related to the human comfort, we can measure in the dBA. Waketon is an electronic frequency weighting network single number rating system that indicated reading of the different frequencies based on the human response in the sound level meter. It will show graph that will be related to the loudness of the noise. So when we plot the graph, maybe we can illustrate to see the top of the noise condition. So when we plot the graph, so sometimes we will create in the lower condition because it's not always constant, because the condition of the source sometimes is depend on the time operational system. Maybe in the peak hour we will create the peak of the noise. Okay, we have a regulation rule of graph that play to describe of the condition certain zone in the workplace condition. So we have graph here for regulation condition. The pattern will be play from the 10 until to 130 of the curve condition regulation of the sound level. So this will be measured plotting from the sound pressure level dB, and then with the frequency. So if they play within the curve around 80, starting around I think 70, around 70, and then we will finish and with the frequency until to the 10,000 frequency. They play with 10,000 frequency. So maybe we can consider, maybe we can conclude if the graph plotting is near to the 10, then we can call this one is very quiet. If the as we know, as mentioned before, if the theater's condition, maybe we can accept in the around 80. So here the plotting graph is around 80. Mean that when the plotting graph of the sound pressure, when the starting, in low frequency is around almost to the 120 of decibel. But when by the time increase the frequency, reducing of the decibel. That's the pattern look like this. Okay, that's how we select or we consider the regulation whether to the 20 condition or 30 condition or 40 condition. So we try to evaluate the condition of the certain zone. And then frequency weighting in A level, we try to cover from the human comfort. So we try to cover the weighting. Maybe the weighting cover is come from the negative 70, mean when we block our ear, mean that we cannot hear anything. We cannot hear because we block the from the source. So we just block our ear from the system, from the environment condition, like the microphone, like the what this one, ear block, ear protector, like the foam system, and then also like the look like the what we call this one e protector, yeah, like this one, like the you know, when we hear something from the radio and we plug in the, yeah, 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 we block from the come from the 70 when the frequency is 10, yeah, and then so on until to frequency increase, the block will be maybe cannot penetrate, yeah, again, so become the uh, negative 50 and negative 40, and then become by increase the frequency, so the protector cannot be blocked anymore to 100%, yeah, so reducing, and then until to zero they will play with the constant. So we hope the ear block will be a block uh, around near to the zero of decibel pressure. Yeah, that's one we call dBA. And then for the uh, A level, and then we can go to the B. Yeah, B and D is waiting network are no longer used. Yeah, because we don't want to implement anymore to the human comfort. Yeah, so C itself. Yeah, waiting is sometimes used to the measure noise from the gun and the explosion. So we use this seat weighting level, yeah, only certain condition, yeah, from the gun and the explosion. So this one is differentiate within the level, different level. Okay, this one is a reading, yeah, reading from the condition in workplace. So the first A weighting is from the negative 40, yeah, negative 40, and then by increasing the frequency, so the ear block will be reduced, yeah, because the frequency become the higher, so we cannot the device cannot block anymore with the 100%, yeah, and then become the hope, yeah, near to the zero, yeah, even though they play with the high frequency. And then with the weighting and the condition of the C, yeah, as mentioned in the slide before, yeah, C will be play with the a gun uh, explosion, yeah. So maybe we can still hear, yeah, from the because the negative negative 5, yeah, so maybe the block we can still hear even though it's not cannot effect to the human comfort, yeah. Okay, that's for the condition description, differentiate within the A weighting level and C weighting level. So, C weighting in network, not that the C weighting doesn't weight the low frequencies as much as the A weighting. The difference between A and C level is sometimes used to quantify the low frequency content of the sound. So, as mentioned in the text, yeah, C maybe not play with the low frequency, yeah. They will play with the high frequency. So, as mentioned in the graph before, the A level weighting is covered in low frequency also. Okay. So I hope you can get the something from the slide there. Maybe that's all for today. Any question from you?
No, sir.
No, sir. No, sir.
Okay. If no, okay, I will. upload all video for your maybe ada ni kan apa nak if you need to revise for the class today, so I will put also this recording class to maybe remind you if you forget something from the today. Okay, that's all for today. But before that, I need to collect your uh, attendance first. Don't go anywhere. Okay, attendance also finished. So if you don't have any question, so we postpone our class until to next week. Okay, see you all. Thank you for your coming. For your attendance. Assalamualaikum and good morning.
Thank you, Doctor.
Thank you.
Thank you, sir.
You're welcome.